In this video, I'm going to provide an overview of the latest design for the SpeedBox Quick Connect mounting system. I'm going to use a ceiling fan here as an example, but the SpeedBox system is equally applicable to lights and chandeliers. In this video, I'm going to demonstrate the basic components of the mounting system. I'm going to show how they work together so that the fixture can get electrical service while being supported. And I'm going to show how the components work with existing OEM fan mounting brackets so that manufacturing costs are lower and retooling overhead is minimized when incorporating that into an OEM design. First, it's important to understand what problem SpeedBox aims to solve. So if you've ever installed a ceiling fan by yourself or even with someone else, you know that it can be physically demanding and a pretty frustrating task sometimes. You need to be able to suspend heavy, awkward shaped loads above your head while working on a ladder. You need to be able to make a series of hardwired electrical connections from the building power supply to the fixture while working around this hanging fixture and standing on a ladder. So SpeedBox is a way to modify the design of an existing OEM mounting system so that hanging or removing a ceiling fan is as easy as plugging in a wall fixture. Let's get started with the overview. Okay, as I mentioned in the intro, SpeedBox is designed to work with existing OEM mounting brackets. So let's start by looking at an example of a fan mounting bracket that's in the market today. This is the construction that we're all familiar with. You've got a metal bracket here that is the support bracket for the fan. And then you've got a ball joint here that fits inside that support bracket so that the fan can move around. So the ball joint fits inside of this C-shaped insert. And this C-shaped insert is actually one of the components that SpeedBox alters the design of to get the quick connect capability. Let's go over and have a look at the SpeedBox construction next. Okay, this is a view of the SpeedBox assembly, and the first thing you'll notice is that we're reusing this OEM hanger bracket. We're reusing that unmodified, so I'm going to go ahead and hide that. The thing that is different is the insert that I mentioned, that C-shaped insert in the OEM version. SpeedBox replaces that with a modified version. You'll see that this version has kind of these sidewalls on the side, and then also has receptacles for building electrical supply wire. That's one thing that's different. The other thing is the ball joint is redesigned, and the ball joint here is a typical down rod, just like you would see. This sort of disc-shaped thing at the top is a ball joint on the inside, so it allows that down rod to swivel so that you can use SpeedBox on a sloped ceiling installation. So let's take a closer look by starting with the insert. I'm going to go ahead and hide that ball joint, and let's zoom in a little bit on what's going on with this insert. So first thing is the bottom of the insert's much like the OEM version, not very different in fact, but what's different are these sidewalls. The sidewalls contain these Wago style push-in electrical connections, and so those receive the building supply wire so you can deliver the electrical service from the building. Inside these holes here are channels that have electrical conductors, copper wire that runs through the sidewall into the floor of the insert and ultimately pop out into these grooves here. These are recessed grooves, and so you would have two electrical leads here in this groove, and then on the other side you would have two more. So they're similar on both sides. This particular design actually is accommodating 4-wire Romex 3+1. So if you've got an installation with a switched light or a fan and a light switched separately, it will accommodate that. The fourth lead is optional, of course. One of the things I'm not showing here is the female receptacles in the bottom of these grooves. I'm not showing them mostly because this is this design was a prototype for 3D printing so that I could understand how the pieces fit together. The other thing is in this particular model, you'll notice these cavities on the back of the push-in connectors. The cavity obviously would not be there. This would be copper lined, and everything in this sidewall would be covered up. But just for the sake of clarity in this model, just so that you know kind of those are things that would not be the same in production. So now that you got a sense for the insert, let's have a look at the ball joint. and we'll see how all that fits together. So I'm going to pull the ball joint up. I'm going to take out my insert, and we'll take a closer look at this ball joint. So the ball joint is pretty standard. I mean, you've got a standard down rod, hollow down rod, so you've got space for the fixture supply wire to come through the top. I've designed this particular version here as a retrofit kit. I don't think it would be designed like this with an OEM integration. I designed it this way so that I could test it, make sure that it works. But this bank of tie-down electrical connections probably would not be there in an OEM integration. I did these so that I could actually test this with real wire and a real fan. But what you've got is fixture wire coming through the middle of the down rod and ultimately coming and tying down into each of these electrical tie downs. On the other side of these tie downs, on the back end, running along the inside of this disc, you have wires that ultimately connect to male electrical pinouts here. Those male electrical pinouts correspond to the grooves that you saw in the bottom of the insert. So if I bring it all together to kind of show you how all of that looks, ultimately what you've got is this kind of assembly. These arrows here kind of indicate the way that this ball joint slides into the gap in that insert, and the down rod rotates 90 degrees along with that ball joint, so it locks in the electrical connections between the male pinouts on the ball joint assembly and the female receptacles on the insert here. I've got another view here to show you kind of what that looks like, since I don't have the electrical leads noted in that particular model. And you can see this is a thicker version of that insert. It's actually a version that would accommodate a wireless receiver, which I'll talk about in just a second. And you can see you've got female receptacles here. They're embedded in that groove, so they do pass the UL finger test in terms of electrical safety and shorting out. And then, of course, you've got the male electrical leads, the pinouts that are in the bottom here. I've got 5 of these pinouts and 5 female electrical leads shown. That is to accommodate certain wireless receivers. Of course, you only have 4 building wires coming in, but occasionally you will, in a case of a wireless receiver, have 5 wires that you need to accommodate DC motors and such. So I do have that shown accommodating them. The other thing I would note is in this particular design, I've got these receptacles and the pinouts shown very close together. I don't think that's not the right way to do this. The way to do this would be to space them across the channel here so that they're completely far away, and you further reduce the possibility of any shorting. But I do have them drawn that way here in this example. So that gives you an idea of how the insert works together with a redesigned ball joint and the down rod, and you can get electrical service from the building into the fixture while also supporting the structure and allowing for freedom of movement of the down rod so that you can work with sloped ceilings. Okay, I think that does it for the overview of the functionality and how it's structured. SpeedBox has a lot of applications. There's a lot of ways you can use this, and I think value add for the business as well as for customers. If there's any questions along the way, I'm always happy to answer them, so don't hesitate to reach out.